Hello everyone, I'm pleased to share with you the Huawei's next generation enterprise-level data warehouse. With the rapid development of 5G, AI, cloud computing, and IoT technologies, industries are digitalizing rapidly, posing new challenges to the data analysis platforms. First, data is growing exponentially. According to statistics, the global data volume will exceed 180 ZB by 2025. Therefore, the scale of the data warehouse system that stores high value and dense data will be increasing. The scale of the data warehouse system will grow from dozens of nodes to hundreds of nodes, and will even to thousands of nodes in the future. This poses higher requirements on the scalability of the data warehouse system. Second, enterprises have entered the era of converged data analysis dominated by structured data. Converged analysis of semi-structured and unstructured data such as time series data, stream data, space data, and text data is the trend in the future. New computing powers such as ARM and GPU are emerging continuously. The system used to mobilize diversified computing power to provide converged analysis capabilities with higher performance. Third, mobile internet and office online carried out through apps have become basic elements of people's daily life, which raises higher requirements on the stable running of data platforms 24/7. Let's look at the development history and trend of the data analysis. The development of data analysis products have gone through 4 phases: single server, cluster, distributed, and cloudification. The first phase was the PC era. In the 1960s and 70s, PCs emerged. The data analysis services mainly consisted of simple query and data aggregation, which was the early data marts. Typical data analysis product was Oracle Single Node Database. At that time, the system featured basic availability. The second phase was the Internet era, from 1990s to early 2000s. The Internet became widely popular. All-in-one appliances such as Oracle, RAC Cluster, Teradata, and Exadata were very popular, and the first TB level and PB level data warehouse systems came into being. The third phase was the mobile internet era. In 2010, e-commerce boomed, mobile internet developed rapidly, and data volume increased unprecedentedly. The Hadoop system based on the general-purpose x86 platform and the MPP database began to penetrate the market. Those systems can process and analyze structured and semi-structured data and feature distributed deployment and high scalability. The fourth phase, which is right now, is called the intelligent data era. In recent years, cloud computing, IoT, AI, and 5G technologies have been widely used. Massive and diversified data, especially time series, stream, text, and video, require further processing and mining. Data processing will be based on the cloud. The collaborative computing through data warehouse and big data will expand the computing boundary. Converged analysis of data warehouse plus AI will align structured and unstructured data and discover more value from data. Therefore, we released the next generation GaussDB real-time data warehouse. It supports real-time convergence analysis of stream data, time series data, and relational data. It is fast, easy, simple, and cost-effective. The first point is fast. Fast import. In typical IoT scenarios in the future, with the increase of number of device accesses, there will be an exponential growth of the data generated instantaneously, which need to be quickly imported. The real-time data warehouse can support a continuous calculation and import rate of up to 600,000 per second for stream data and up to 100,000 per second single-node performance for time series data. In addition, it supports linear expansion based on the data volume of cluster nodes. Second, fast computing. It supports continuous stream computing and query based on stream data definition and semantic definition of complex stream computing based on SQL. It also supports rolling and sliding time window to implement real-time analysis of stream data by time granularity. Second, easy. It supports semantic definition of complex stream computing based on SQL, which simplifies application development. Take a Druid monitoring scenario as an example. With SQL statements, we use 150 lines of code to implement the same functions as the original 1,900-line Druid scripts. It supports real-time multi-dimensional analysis, so that a multi-table correlational query can be performed for relational tables and time sequence tables. Third, simple. One platform can implement continuous computing, rule computing, pre-aggregation, and time sequence computing, which significantly simplifies development and O&M. GaussDB features high compression ratio. Time series data has certain inherent rules. The real-time data warehouse uses adaptive compression algorithm to achieve a compression ratio of up to 40:1, greatly reducing storage space and the user cost. The release of real-time data warehouse was not achieved overnight. In fact, we have been working in data warehouse field for nearly 10 years. From the end of 2011 to 2013, we set up database R&D teams in multiple regions in and outside of China. We started product prototype development and verification and made breakthroughs in basic distributed architecture technologies such as distributed framework, role storage, and HA. In 2014, our data warehouse products were put into commercial use for the first time. Our products have basic features of modern data warehouses such as data partitioning, column storage, vectorization engine, and compilation execution. From 2015 to 2016, we continued improving products together with customers and started setting up benchmark cases in the finance, government, and telco industries. We also made breakthroughs in advanced features such as large-scale cluster communication, dynamic load management, and SQL on Hadoop. By 2019, GaussDB has been put into large-scale commercial use, with more than 300 commercial cases of key accounts. In addition, the product added innovative features such as multi-tenant, SQL on OBS, and a global consistency backup and restoration. Up to now, more than 1,000 customers worldwide have chosen GaussDB to build their core data warehouse systems. In addition to these next-generation competitive edges of real-time data warehouse, GaussDB won the trust of many key accounts because it has solid capabilities. Its three core features are large, fast, and stable. The first feature is large. Based on the shared nothing distributed architecture, GaussDB achieved breakthrough in key technologies such as large-scale communication and large-scale cluster management. Its design specifications reach 2,048 nodes, which enables high scalability. GaussDB can start from a small scale and can be expanded to hundreds of thousands of nodes on demand. The cluster performance and capacity will increase linearly as the number of nodes increases. For example, one key account has built a GaussDB cluster that will soon exceed 480 nodes and nearly 10 PB of data. In addition, we are operating more than 10 large clusters with PB level or higher data volume stably. We continue optimizing core technologies such as communication, cluster management, and optimizer to enable GaussDB to effectively support 100 PB enterprise core data warehouse systems in the future. Next, let's look at the second feature of GaussDB, fast. First, GaussDB features a multi-layer full parallel computing engine which supports parallel computing of multiple physical nodes. Within one physical node, it supports parallel computing of multiple CPU cores, and within one instruction sequence of a CPU core, it supports SIMD instructions, so that one instruction can operate multiple data at the same time. It can be said that the GaussDB maximizes the parallel capability to provide ultimate performance. In addition to full parallel capability, Huawei also implements core technologies such as next-generation intelligent optimizer technologies, efficient operator algorithms, and dynamic compilation. With parallel computing power and efficient instruction, we can implement ultra-fast data loading and analysis. Currently, in commercial sites on the Live Network, we have realized TB-level data import in minutes and association analysis of 10 billion lines of data in seconds. As an enterprise-level data warehouse product, GaussDB's third important feature is stable. All components of GaussDB, such as CN, DN, GTN, and CM Server, can be deployed in active-active or active standby mode to ensure smooth switchover when a single component is faulty. In a product deployment solution, critical hardware such as disks, switches, NICs, and host power supplies are deployed with redundancy networking design. In addition, during large-scale commercial use, we have improved and implemented comprehensive software and hardware fault detection, including faults of switch, NIC, disk, RAID controller card, host, hardware sub-health, and cluster software instance. Due to the multi-layer backup of hardware and software and comprehensive fault detection, when a hardware or software fault occurs during cluster operation, the cluster can quickly detect and respond to the fault and automatically switch over, ensuring data integrity and the service continuity. In the future, GaussDB will continue to innovate and evolve. We will keep making efforts and optimize the following 5 aspects to build a new generation all-scenario cloud data warehouse. First, continue optimizing the enterprise-level kernel capability to support larger cluster-scale, stronger real-time analysis, and higher system reliability. Second, faced with cloud, we will continue optimizing wizard-based full-process ONM capabilities with online visibility, and online, fast, and elastic scaling capabilities to build a cloud-native data warehouse. Third, continue optimizing data collaboration capability to enable one cluster to support multiple service systems of different types, making data collaboration and analysis across data sources, regions, and clusters simpler and more efficient. Fourth, keep exploring new hardware capabilities to enable products to adapt to more hardware platforms. On the other hand, keep drawing on new hardware dividends and software-hardware joint innovation for stronger end-to-end system capabilities. Fifth, continue expanding the data analysis boundary and realize the association and converged analysis between AI and BI, structured and unstructured data, and real-time and historical data. Lastly, to harness the rapid growth of massive and diversified data, GaussDB will keep evolving to provide customers with competitive, all-scenario, and cloud-based data warehouses. That's all of my sharing today. Thank you.